This is, so we'll start with case 1, y equals x to the n. So it's basically y equals mx plus c, but it looks different. Let's take a look at this thing. So you start off with an equation, y equals x to the n. So that's some kind of exponential. The power is n. You get it in terms of log y. So log y equals two different things. And then this is like the m, the thing in front of the log x. And then the other one is the c. So we'll just try it. And usually an exponential graph kind of looks like that. If you do log x and log y and it makes a straight line, then it's an exponential. Okay. Let's try this one.
So log one, log two. Would I just have to do like, for example, for Birmingham, it says rank. Would I have to do like log two or?
Yep. I'm just going to leave it as log 2.
Okay.
Okay.
If you continue, just put like log three, log two, log five, log six.
Yeah. And then how about the other one? Oh, sorry. Well, they said to 2 decimal places, but okay, I think you get the idea for that one. And then how about the bottom one?
So I just went to my calculator, like log a million, and then just get the first 2 decimal places. Or...
Yep. And I'll put in log 2, log 3.
So for log a million, it gave me just one answer.
What was it, sorry?
It just says 6.
6?
Yeah. Log 3 is 5.86.
Log 3?
Yeah.
Don't worry about those, just the bottom ones.
Oh, right. Do you mean like B and C?
6 was the 1 million, was it?
Yeah.
So what is 730,000?
It says 5.86.
Oh, sorry. I thought you were saying log 3 equals 5.86.
Oh, no, sorry, 86. That's it.
5.86. Okay.
Our next one was 5.79. My next one was 5.72.
5.72. Yep.
And my final one is 5.68.
5.68. Okay. How would you do part B?
Did you just make it into like just like a regular graph?
Yeah. And then How would you do part C once you have the graph?
Values of A and N to 2, 6. So
So you would have some graph, and it would look something like what is this? 0.30. So it would be look something like that. Oh, I don't know. That's when it's. And so, how would you get M? How would you get? Hang on, A and N.
I think, would you go across like the p-axis and go up to one of the r values, and then just make them equals to the formula p is equals to a r to power of n or something?
Let's see. So we have N. Just want to see what is N. Where A and N are constants, we did log R. So what you could do is to get A. Was it A? Yeah, to get A, that's when N is 0.
Right. Yeah.
And you could do it that way. So let's just do this in general. They're just kind of showing you where it comes from. P is equal to A R to the power of N, I think it was.
Yeah.
Yeah. Log both sides. What do you get?
Log p is equals to log a r to power of n.
And then use log rules to split up the right side.
Would you I'm not allowed to do like n to the front of the log, can I?
You first have to split these up. This is a times r to the n.
So it needs to be rn times r to the n times a.
That'll be the same thing. What you can do is use logs in reverse, and so that would be 2 logs being added.
Oh yeah.
And then you can do your n thing.
So yeah, and then when you just move the n to the front,
then you move your n to the front. And so basically, in this case, r was like the x. I'm just going to swap those two around. And the other one was like the y, like the y-axis. On the y-axis. And so log p, that's like your y. N at the front is your m. Log r is like x, and then the thing without the x is the plus c. And so if you had a graph, the gradient is you'd get the gradient of the line, that would be n, and then the y-intercept is c. So if log a is equal to c, then how do you get a?
You do something like c divided by log 1.
Opposite of log is to raise both sides to the power of the base.
Oh.
And logs by default are at base 10.
So is a just c to the power of 10?
10 to the power of c.
Power of c, okay.
Yes. So yeah, 10 to the c equals a. And so that's how you can get the gradient and the intercept. And you can do it from the graph, but it's much easier to do it this way. Let's just see what they did. Okay, so this is your graph. So we had some data. Yeah, this was our data that we had. We put the log of the r, the log of the p. We plotted them on a graph and it makes a straight line. That means it's an exponential. And the way you find the so you find the gradient, that gives you the n, and then you find the c. So I believe it would be 10 to the power of 6.2. Yeah. Log a equals c, and do it that way. So they did this. So that was the gradient, and then log a is 6.2, so 10 to the power of 6.2. There we go. Any questions about that?
No.
Real practice. So this is a different form of it. This is when x is in the power. But similar idea. But hold on. So yeah, let me just see this one. Am to the b. R equals am. Yep. Okay. Exam question. How do we do this?
Okay. Okay. So do I need to just first of all copy and complete the table?
Yeah.
So
let's just do the very last one.
okay. So that would be r is equals to a 80 to the power of b.
The bottom row is log r, the top row is log m.
Yeah.
And this is m, this is r.
Sorry, are we still doing a?
Yep.
So
So did you say we would be subbing something into this thing? Is that what you said?
I thought we were doing D for some reason. I don't know why.
Oh, okay.
So shall I just give the next values basically?
Just the last one. We'll go in the last box.
Yeah.
That's why you were doing D, because I said the last one. No, just the last empty box there. How would you get that?
So my answer for the last one is 2.81.
And how did you get that?
I just put in log 650.
Yeah. If you're able to do that, you'll be able to do those three. Okay. How would you do question B?
Yeah, again, just put into a graph, and if it's a straight line, it's exponential.
Yep. And plot a graph of that against that using the values from your table and draw on a line of best fit. Okay, and you know from GCSE line of best fit. How could you then do part C?
Is this where I have to like log both sides and stuff?
Yep.
So is this log R equals to log A plus log M to the power of B?
Mm-hmm.
And then equals to, so log R is equals to log A, oh no, or even, sorry, B log M plus log A. And then that's like our y equals mx plus c, isn't it?
Yeah.
And then so to find out the values of it, would I have to do like log r minus b log m to get to log a? Or
You could. So what they're saying is use your graph, and so how could you use your graph to get the value of b?
So I don't know. Would you have to like sub in the r's or something like that? More rich.
What does the b match up with in y equals mx plus c?
M
Yeah. And how do you usually get m from a graph?
gradient.
Yes, and it'll be line of best fit, so it's straight line. And so, how do you find the gradient of a straight line?
Y2 minus y1 over x2 minus x1.
Yep. And instead of using the graph, let's use the table.
So okay, so would that be like 2.81 minus 1.52
Mm-hmm.
over 3.88 minus 0.62?
Mm-hmm.
My answer. Shall I just give it as in the fraction, fraction form?
Yeah. Okay. Yeah.
433 over 326.
And they said 2 sig fig. So
All right. It says fine. So the answer is one for B is 1.33.
So let's say 1.3. And
Yeah.
it's good to have the exact fraction in case we need it for something else. So that is B. Now we need A. How do we get A?
So A is C. Usually, what you would do here, you'd sub in the y, the x, and the m, and then just be left with the c, and then use it, and then you can just solve it like that.
So let's do it. Sub in.
So well, I do 2.81 equals to b basically 326 times x plus c.
Hold on. So 2.81 is log m.
Oh, right. Okay.
So it's like the first one is like the x and the second one is like the y.
Does that mean that we did the first one wrong?
No, this is correct. Oh wait. It should be the other way around. It should be 326 over 433. You're right.
Okay.
So what is that?
It's just the fraction, yeah, the other way around, yeah. And it says, to see the figure, it's 0.
Say that again.
0.8.
0.80?
It's 0.75, so.
Because that has 2 sig fig, because 0 doesn't count as a.
Oh, yeah, sorry.
Has no significance. Yeah. Okay, and yes, y equals mx plus c. What do we get?
I just did something like 3.88 equals to 0.75 times 2.81 plus c.
Mm-hmm. And you could use the fraction 326 over 400 or answer just to make it more accurate.
Um,
Log m
I
2.8.
got 1.7725.
So 1.7725. And what does that answer represent?
That represents a.
That represents log a.
Oh, so log a is equals to 1.7. Oh, and then so the base. So does that mean that 10 to the power of 1.7725 is equals to a?
Yes. And so c is 10 to the 1.7725. And so what is that to 2 sig fig?
It says the answer to that is to 2 sig fig, so 59.
Okay, so that is roughly 59. So 0.75 and 59. And that's like the gradient, that's like the intercept, I think. So b is 0.75 and 60. Did it round to 60? 59.
I don't know.
Was it 59.5 or something? Actually,
Maybe.
they might have rounded early, actually. They said A. They said 10 to the 1.78.
Yeah.
So they rounded too early. They should have left it the way you did. Our one is better. Our 59 is more accurate than 60.
When I said it was round, yeah, sorry. It was 59.5.
Oh, was
Yeah.
it? Ah, okay.
Yeah.
You just sneaked in. So 60. Okay. 2 sig fig, 60. Okay, so the way they did it was with the graph. It's just you could so easily make a mistake there to say like that's 61 instead of 60, or to say the gradient is 0.75. It's much easier. I just want to see, how did they get gradient? Yeah, they did gradient same way. y2 minus y1, x2 minus x1. Always choose first and last for most accurate. And then they did it exactly the same way. No, they did the intercepts just by reading it off the graph. So 1.78. There's no way you could read 1.78 off the graph. It's much more accurate to go, sub them in to get C that way. Let's see. So complete the table, that's all right. Just do the log of each thing. Then plot the graph. It's just a normal graph line of best fit. Gradient of the graph is y2 minus y1 over x2 minus x1. We just have to make sure that's the right way around. And then to get the A, oh yeah, so this one, C isn't A, C is log A. Okay. And so sub in the y, the m, the x, and get the C, which is log A. So log A is equal to that. And so A is 10 to the power of that. Oh, hang on. D. Using your values of A and B, estimate the resting metabolic rate of a human male with a mass of 80. How would you do that?
Sorry, what am I meant to do, sorry?
Part D. We forgot to do it.
Oh, right. Using the values of A and B. So, would I just need to just sub in A, B, and M into that to get the answer?
Yeah, that's exactly what you would do. Do you want to try it?
Yeah. So, um,
and what would you sub it into?
would I just do 60 times 80 to the power of 0.75?
Yep, perfect. Go on, try that, see what you get.
I got 16,004.9. So basically 16,005, basically.
16,005?
1,605.
1,605. There you go. 1,605. Great. Kilocalories per day. Any questions about any of that?
They won't like mark you down for not putting the measurement at the end, like calories per day, will they? Or-
Kilocalories per day. Using values. I'm not sure, but yeah, you really should put in the. I think you'd get full marks.
Yeah.
Yeah, I'll just try to remember. Any other questions? Okay, so that's that one. Let me just see. That was AM to the B, AB to the T. Okay, let's do the other type then. Case 2 is when x is in the power. What does this look like? You take logs of both sides. X log B. Ah, yes. So for this first type, let me just make sure. For this first type, the gradient was so it was like log x, n log s, yeah, and then for this one it will be x and the gradient will be log of something, I think. So let's try taking logs of both sides for this one. Y equals AB to the x.
Would that be log y equals to log a plus log bx?
Mm-hmm.
Will that just be log y is equals to b log? Oh no, sorry, x log b plus log a.
Yeah, and so this time, if I was to just swap those around, log b x log a. Yeah, so this time the gradient is the log, and the x is just the x. Okay.
Okay.
And oh, hang on. Seems a bit easier. Let me just see. Yeah, the gradient is log b, and the other one is log a. All right. Okay. How about this?
So. Do I just need to sub in 0.6 and 0.2 into that equation?
Write an equation for the line. I would.
Oh, do I just do y equals mx plus c here?
Yeah, but I
So,
would. Sorry, go on.
no, sorry, go
on. This isn't t and p. This is t and the log p. So your y equals mx plus e would have to be for log p.
So, do I need to start off with log p equals to ab to the power of 2? Or?
Yep.
And then log p is equals to log t and then log b. Oh no, I don't need to do that, do I?
Yeah.
All right, plus log a.
Mm-hmm.
And then, so is the x here going to be t, and then the m is log b?
Mm-hmm.
So
I'll just swap those around. It's the same thing though.
Is that the answer to A?
Write down an equation for the line. So now let's actually sub in the stuff you were saying.
So now, um, graph has a gradient of 0.6 and meets the vertical axis of the zero. So do I need to do? Oh, I need to now get log a, don't I? So it'll give me. So just sub in 2 into what? Into log p, 0 into log t, and then 0.6 into log b.
Yeah.
Uh, I've got C is like 0.3. Oh no, not C. Oh yeah. Oh sorry, I got log A is like 0.3.
And what did you sub in here?
I subbed in I don't know if I've done the right thing. I can't really go back now because I put answer after.
Okay. So you said sub in 0.6, 0 and 2. So the gradient, the x and the y. So
Oh no, sorry. Sorry, it says C, log A is 2.
yeah, log a is 2. And so
Saying that 10 squared is equals to A.
yeah.
So
And so what is a?
100.
Yep. And what's next?
So I need to get part B now. Um, um, I'm not sure. Do I need to sub with the 100 in somewhere?
When you said part B,
Yeah.
do you mean like question B or this
Yeah.
B thing? Question B. So you've already done half of it.
Yeah.
Part A, you need the equation of the line as like log p equals. We want the equation of the straight line, this one. And so log p equals mx plus c. What is that?
That is log B.
What is log b?
Um, log AB T. Log.
Log b matches up with m. So it's the gradient.
So the gradient is log B.
Yep. What is the gradient?
0.6.
Yeah.
So does that mean that 10 to the power of 0.6 is equals to P?
You don't need to find p. We just need log p equals 0.6 x plus c. So what is x? What is c?
X is
X is just t.
Yeah, plus log 100.
Let's see. So c is log a,
Yeah.
and a is 100, so log 100. Yes, I believe that's it. And actually, hold on. What is log 100?
Log 100 is 2.
Yeah, and we actually got that up here. So you accidentally did the first half of part B. So this is all you need for part A. So y equals mx plus c. Instead of y, it's log p. Instead of x, it's t. Log b is the gradient, so that bit is 0.6. And log a equals 2. And so plus 2. So for part B, we said a is 100. Now we need to work out b.
Okay. So so log b is equal to 0.6.
Yep. Log b equals 0.6.
So could you just do 10 to the power of 0.6 on?
Mm-hmm.
And so would the answer be? Yeah. So the answer would be 3.98.
3.98. And part C.
Constant A in this model. Is A just like the starting value of bacteria?
Yes. Let's say initial amount of bacteria, initial population of bacteria. Yes, it's basically when time is 0, population is A. B to the power 0, A. Let's just check our stuff. So that's the initial size. Log P is equal to 0.6t plus 2. And that one was 3.98. And A was 100. Yeah. So they give us P equals AB to the T. And the graph was for T and log P. So you have to get log P. So log both sides, do the thing. Y equals mx plus c. So m is log b, and m was 0.6. So log b is 0.6. You use that to get log a. And so the equation of the line is log p equals 0.6t plus 2. So mx plus c. Then you get a and b, which you're pretty good at. And then c sub in 0 for t. Yep. Any questions there?
No.
Tricky. Undo exam question. This looks similar enough. Yeah. Hang on. So this one is just, that's okay. Plot the graph. So yeah, draw a line of best fit. Use a graph to estimate A and B to force if you just want to see what else. This looks good. Yeah, let's do this one.
So I need to do something like log p equals to log a b to the power of 2.
Mm-hmm.
And then log p is equals to log b is the power of t plus log a.
Mm-hmm.
And then that gives me the y equals mx plus c, doesn't it?
Almost, I think.
Do I need to move t to the front?
Yeah.
So t log b plus log a.
Yeah.
So and then so that's y equals mx plus c, isn't it?
Mm-hmm.
So t equals 0, correct. So I need to do b now.
But you need the specific values.
Oh right, yeah. So do I need to sub in? Do I need to get the gradient by doing like 3.7 minus 5.2 over 20 minus 0, or
Yep.
okay, and so I got minus 0.075.
Okay.
And so do I now need to do I need to just take, so do I need to do 3.7 is equals to t oh no, sorry. Is it 3.7 is equals to minus 0.075 times 20 plus log a?
Mm-hmm.
And then I'll for log a. And so that would be I got log a is 5.2.
Yep. Y-intercept. Log A is like the C.
Yeah. So log p is, do I need to scale what a is?
That'll be part C. So
Yeah.
what is the equation of this straight line?
Log p is equals to t log b plus 5.2.
Okay. So log A is the intercept. That's the C. That's 5.2. When we write the equation of a line y equals mx plus c, you need the c and the m.
Yeah.
So what is the other bit?
Just the gradient. So minus warp p equals to minus 0.075 log p.
No, that's what I was afraid of. What is the x?
I'm guessing it'll be t then.
Yes, x is the t. So x-axis in here is time axis, and so this bit here, I usually just swap them around. So at the moment it's xm plus c. I just swap them around, so it's mx plus c. But that's it. That's part A. Part B.
So I just need to sub zero into, so it will just be that log p will be equals to 5.2.
Mm-hmm.
Do I need, is that it for log P? Or do I need to get P?
They want the population.
So would that just be 10 to the power of 5.2,
Mm-hmm.
which will be 158,489.3.
Let's say 158,000 people. They said to 3 sig fig.
Yeah.
See.
So log A is equals to 5.2. So 10 to the power of 5.2 is equals to A. So it says that A is equals to the same number.
Mm-hmm.
And for B, so so minus 0.075 is equals to log B.
Mm-hmm.
So does that mean that 10 to the power of minus 0.075 will give you log B?
Yep.
I got 0.841.
And part D.
So just 0.841 times 158. No, 0.841 to the power of 30 times 158,000.
Yep.
It says 876.
And that is 876 people. And let's take a look. 59 people. So minus 0.075. That's 5.2. So B was 1350 people. We were way. How did you? Yeah. Hang on. Find the number of people in the venue when time is 0. When time is 0, the population is A. Log. Where did that go wrong? 0. Oh, that's why. Look, they just it's base 4, not base 10.
Right.
So it's 4 to the power of 5.2. So wherever we put 10, it should be 4. I just didn't notice that. That's cheeky. Okay, what is 4 to the power of 5.2?
It's going to be 1,350. Yeah, 1,350.
Okay, and so A was 1,350. And so B would be 4 to the power of that. So just check that one.
It says that B is 0.901.
And then sub those in to get P. Use those to get P. 30 minutes.
Yeah, so would it be 1,350 times 0.901 to the power of 30? And I got 59.2.
So let's say 59 people. And yeah, so it's all correct. Yeah, Oh, sorry, I just the default base is 10. This one they specified it's 4. I just didn't notice. Great. Any questions there?
So when it says like find the number of people half an hour after the so if the answer was, for example, something like 59.6, would I round that to 60, or would it still round down to 59 because you can't have like half person?
It's just an estimate, and so you'd say 60.
Okay.
Because, like, there's 59 or 60. So this is what's called a mathematical model.
Yeah.
It's like a simulation of reality or something, like an equation that kind of gives you an estimate. So it can never be exact, but it'll just be an estimate. So you just pick the closest one.
Yeah.
Any other questions?
No.
Let me just take one last look at this. So it's an exponential thing. Equation shown on the graph. So that's the C. You do the gradient. That's okay. Use those to get A and B. So you did all of that. 3 sig fig. More people half an hour. Yeah. So the half an hour thing, you just need the unit is important. So T minutes, and that's why it was 30. That's the only thing I was thinking of. But we did one exam question of each. The important bit for these. So you can actually, smart people with good memories remember that log A is C, and so they would just know that 5.2 is log A. But I always have to do the whole thing of like log both sides and rearrange it. I suppose the important bit is remembering that T is X for this one. And so this is like these models, they apply it to the real world. So it's very common that the X is time. Very common that time is used for X. And so it's good to swap these two around so that the M comes first and the X comes second.
Yeah.
So just watch out for that. Okay, let's just take a quick look. This was last time. So this is what it all comes from. This was the first type, y equals mx plus c, where m was just the power and x was log x. The second type was x is x and m is log of something, in this case log b. So yeah, first type it's log x, second type it's log b for m. But the method is the same for both of them, just logging both sides, making it look like y equals mx plus c. They give you a table of values, fill in the table, draw the graph, and then use your graph then to find gradient, intercept, and to estimate stuff like their rank and stuff. Let's see. Yeah, so you could, in theory, like go up, hit the line, go across, and read it off. But once you have the equation of the line, it's more accurate to use the equation to estimate stuff. Yeah, it's straight line, so it's exponential. Let's see. Yeah, so these are simpler than they look. Like this one here, 0.6, that's the gradient. And so it's 0.6t. It goes at 2, so the intercept is just plus 2. So instead of y equals 0.6x plus 2, it's log p equals 0.6t plus 2. But going through the steps means you don't have to remember which one is which. That one's okay. A is the initial value, initial population. You just put it in the context of the question. So this one, fill in the table. How do you find the gradient of the line?
Just y2 minus y1 over x2 minus x.
And which y's and which x's do you use? Which two?
So in this case, it would be log m2 minus log r2 over log m1. No, sorry. Log m1 Would it be log R2 minus log R1 over log M2 minus log M1?
Yes, but which
Oh, sorry.
equation?
So 3.88 minus 0.62 over 2.81 minus 1.52.
Yes. So in theory, what you could do is use the first two. Like if we had
Yeah,
gotten this one, you could use those two, but it's best to use the first and last because it takes into account the whole line.
yeah.
So it'll be like as accurate a gradient as you can get. And then C is that bit is okay. Yeah. Oops. Let's see. That's okay. And I just didn't want to spend a long time like drawing a graph because you know how to plot a graph. And
Yeah.
when it comes time to actually get the gradient and the y-intercept, you're going to calculate them anyway. It's just much more accurate. Like they said, the gradient is or the intercept is 1.78, but actually it's much easier to do like 10 to the power of 1.7725 to get it accurately.
Yeah.
That was okay. And then we did the other type. Just watch out. You got this all totally correct, except for replace the 10 with a 4.
Yeah.
That was it. Yeah, how was that for you, Andrey?
That was good. Thank you.
So finally, we are finished pure. So now it will be stats and mechanics, and what you'll find is you'll be able to do like nearly a whole chapter in one lesson. It won't be like this where it's like grueling and punishing. It was just because it's the very last chapter in pure. Any questions for me in general?
I don't think so.
All right, well done, Andrey. You did great. I look forward to chatting again next time.
Okay, thank you. Bye.
All right, have a good one. Goodbye.